Hello, assalamu alaikum guys. How are you? Hello. Can you guys hear me?
Walaikum
Yes, sir.
Assalam, teacher.
Waalaikum.
All right. So you guys can hear me now. All right. Let's continue forward. So in our last class, what we did was that we studied what was factorization, and we saw, how there can be simpler ways of doing factorization by just taking out common stuff. And the other bit is just, simply when you're given some sort of a general response and what your response is going to be through that. Now, what we're going to do is that we're going to do another branch of factorization, which is going to be what you may call middle term breaking. Now, this is one method in factorization, like one of the methods of factorization, which we're going to study for today. So, whenever we're doing middle term breaking, like for example, you're never going to be asked by the examiner to do middle term breaking. Like it's never going to be said in a question, it's never going to be stated. This is something that you have to identify yourself. How you're going to identify? You're going to identify by looking at the shape of the question. The question is going to be as such that you're going to be it's going to force you to solve your question by using middle term breaking as a last resort. For example, I'm going to attempt this in a generic and general form. Let's just say that, there is what you may call a quadratic expression ax squared plus bx plus c. And, you know, a, b, c are constants over here. We know that already. So a, b, and c are constants here. And what we need to identify is that obviously there are going to be some sort of numbers. The question is not going to be as vague as this. This is what I'm writing generally in a general form. Now, what's going to happen is if you are given a question and it's not going to state that you have to solve through middle term breaking. So obviously the other way around would be the fact that it's going to be you're going to have to use some sort of other method. Now, just by looking at this expression, if I can visually realize that it cannot be solved via factorization, simple factorization, there's nothing common in between them, or they cannot be expanded or broken down, or any of the factorization toolkits cannot be used, then I'm going to resort to middle term breaking. Now, what happens in middle term breaking is that it's pretty simple. The middle term is bx. What you're going to do is that you're going to break down bx into such two numbers that it is going to be, let's just say that, these two numbers are, just give me a moment, guys. All right. So you're going to break down bx into two such numbers, like, for example, let's just say m and n. M and n of what? Mx and nx. Let's just say that. You're going to break down the middle term into two such numbers, such that if these numbers are added or subtracted together, they form bx again. Clear? You have to break down the middle term into two such numbers that if they're added or subtracted, they make bx again. They make the middle term again. Secondly, what you're going to have to consider is that these two terms need to be multiplied, m and what you may call n. They are going to be what you may call only m and n, not x. If they are multiplied together, what you're going to have is that if m and n are multiplied together, they should form c. That's the two conditions that you need to put forth. All right. That's the two conditions that you need to put forth. All right. Firstly, you Vx should be broken down into two such numbers, which are mx and nx. Any two numbers, m and n, are also constants. And what is going to happen that these two numbers, if they are multiplied together, they should form C. Once that is the case, what you're going to do is then your entire expression will be in an expanded form. And what will that help you with is then you can simply, use factorization to get your answer. But there is one major, um, what you may call the property that you need to know. Like there's a prerequisite that you need to know. And also M and N are constants as well. So what is going to happen is that the first thing that you need to know regarding this question is that first of all, the coefficient of A should be equal to 1. You should be, in order to solve this question, you should first either at least try to make this the coefficient of A, the coefficient of x squared equal to 1. Is this clear? Now, let's do a question. Let's do a simple question. How do you do middle term breaking? Consider a question like x squared minus 7x plus 10. All right. Just give me a moment, guys. All right, guys. So consider an expression x squared minus 7x plus 10. What I'm simply going to do is that I need to break down 7 into two such terms that if they are added or subtracted together, they make minus 7x. But if they are multiplied together, the constants of those terms make 10. Now, the only thing I can think of is, breaking down 7 into two such terms, like, for example, and by the way, the sign is always with the number. If it says minus 7x, that means that this is minus, the entire number is minus 7x. So if you're breaking it down, you need to break it down into two numbers which add up or subtract to minus 7x, not 7x alone. So now what's going to be the case? The only number I can think of is minus 5x minus 2x. And the reason why I can think of these two numbers is because minus 5x minus 2x makes 7x. And if you multiply minus 5 times minus 2, it makes plus 10. Minus minus cancels out. Then, upon this consideration, what I can think of is that I can simply write this down as what you may call x squared minus 5x minus 2x plus 10. Clear? Then next up, now it's become a bit more easy to do because now you can see that, so you've got some sort of like terms forming and you can easily factorize them. How am I going to do that? I'm going to group the like terms and it is going to be simply, like, for example, taking out x common, it's going to be x minus 5 in the first bracket minus 2. Now, if I take 2 out common, minus 2 out common, it is going to be x minus 5 in the second bracket. Now, because these two brackets are repeating, I can simply rewrite this down as what you may call um, x minus 5, or you can say x minus 2, x minus 5 as your answer. You've simplified a quadratic expression into something which is much more similar using middle term breaking and your brackets. Hopefully, this is clear. Now I want every one of you to do one similar question like this. This is really easy. Um, let's think of what you may call x squared minus 14x plus 24. All right, guys, I want you to solve this question by middle term breaking. Okay, kindly do this and let me know. Let me know when you're done, guys. Yes, Zoya, done.
Yes,
Zoya, what's the answer?
x minus 2 and x minus 12.
Okay, guys, Zoya is saying that the answer is x minus 2 and x minus 12. So this is fairly simple. Like I don't think we need to go through much more examples of this because this is something that is completely understandable as to what is happening. You're simply going to break down the two terms into two such terms that if they're added or subtracted, they make up the middle term again. But if they're being multiplied together, they make up the third term. Is there anyone who's getting a different answer, or is there anyone who does not understand this? Let me know. All right. Hopefully, this is clear. Now we're going to move into our third aspect, which is completing the square. This is the reason why I was treating this separately, is because of the fact that, the questions regarding completing the square, again, it is going to utilize factorization. But what is going to happen is that what you may call whenever you're trying to complete the square, the examiner is going to ask you a question separately. It's not going to be a factorization question or a simplification question. It is actually going to be stated in the question that you're supposed to do completing the square. But it's not going to be stated so bluntly. All right. So bluntly, as in, like, for example, it's not going to be stated that express or simplify the expression using completing the square. No, how the question is stated is that the question statement is going to look like this. Like, for example, it is going to either say write, or the question could say simplify the expression in the form of in the form of what you may call a x plus b whole squared plus c, or in the form of x plus a whole squared plus b. So if your question is being stated in this form, that if the question is specifically telling you to write down your answer in this form or in this form, where there's a square term and x is there, an entire whole bracket is being squared with x, then you should just know blindly that he's asking for completing the square. He's asking for nothing else apart from completing the square. Now what's going to happen is that how do you do completing the square? Again, I'm simply going to what you may call write down the general form of a quadratic equation, which is ax squared plus bx plus c. Then the first condition is extremely important. Do not attempt the question without this, otherwise your question will be wrong. the value of a needs to be equal to 1. Otherwise, the question cannot go through. And the reason for the value of a being equal to 1 is that, for example, you guys will notice this as you go along. Probably it will be much more better explained in A levels when we do transformations. Is that when the value of a is not equal to 1, let's just say 2, 3, it messes up the entire sort of form. All right. So technically, it multiplies everything. So whatever answer you were getting, think of it as being multiplied. But we're trying to get a simplified answer. And in order to get a simplified answer, you have to make sure that the value of the coefficient of x squared, which is labeled as a over here, is 1. Now, what is that? If, for example, let's just say a is not equal to 1, then you have to make it equal to 1. All right. You have to factorize, cancel down, add, subtract, whatever you do, you just have to make sure that it is equal to 1. Secondly, what's going to happen is that you're simply going to, now this part's a bit trickier to grasp. Once you have determined that the value of a is equal to 1, you can move forward as ax squared plus bx. But this is where it gets different. What you're going to do now simply is you're going to take the coefficient of the second term, which is b, and divide it by 2. Also, you're going to whole square this new term that you have created by dividing b by 2, the value of b by 2. Secondly, because you're adding something into the equation by yourself, obviously you're going to have to counter it. And how do you counter it? You're going to subtract it by the same number. And the rest of the equation is as follows, whatever it was. This is just the two introductions that you have done into the equation yourself. What have you done? You have divided the coefficient of x by 2 and you whole squared it. And what you're doing it, that you're adding it as well as you're subtracting it. What is this going to do is that now you're simply going to isolate this part. This part. I'm going to isolate this part alone. And how I'm going to isolate this part alone and why I'm going to do that is because this part, when you guys do questions, it will become much more clear and apparent. This part is supposed to resemble this a squared plus b squared, oh, plus 2ab plus b squared. This entire part, I know it's difficult to understand how, but this entire part is going to resemble this. And what is this equal to? This is going to be equal to what you may call, if you look into our previous algebraic factorizations, this is equal to a plus b whole square. Just give me a moment. All right, guys. So this is supposed to resemble a squared plus 2ab plus b squared, which we know that can be, simplified to a plus b whole squared. Now, what is going to happen? Therefore, you're going to write this entire thing down as what you may call a plus b, or you can say ax plus b whole squared, and this minus b over 2 whole squared, and c, because of the fact that b squared and c are constants, they're simply going to become, act as, uh, you know, a single constant. So whenever they say that, express your answer in this form, what is that going to do is that you're going to solve this separately, and whatever is going to be inside the bracket, that is just being whole squared. That is how you do completing the square. Now, let's make this simple and let's make this, easier to understand by doing an example. Because I know that this is not easy to understand in a generic form. I'm going to use the same example that I used above so that I can show you guys that multiple factorizations or multiple methods can be used to factor something. For example, this is my term. What I'm going to have is that, wait, how about I use this one? Because the x square minus 7x1 is going to give me an answer in a decimal, and I don't really want that. Let's use this one. What is going to happen is that simply I'm going to rewrite this down again. So it is going to be x squared minus 14x. With the exception of that, I'm going to add half of b. Now, where was b? B is 14. Half of b is equal to 14 over 2, and I'm a whole square it. So I'm going to whole square it minus 14 over 2 whole square it, and the rest comes as it is, plus 24. This will simply be, this can be further written down as, I can simplify this. Now, if I simplify this individual part, if I simplify this individual part alone, I think that it is going to be, it is going to look like x squared minus 14x plus 7 whole squared. So it is going to be plus 7 whole squared, or you can even write, 49. That is up to you. Like, okay, let's write 49 because 14 over 2 is 7, and that is going to be whole squared is 49. Judging by the look on this, can we say that, for example, this is similar to a square plus b plus minus 2ab plus b squared? Because there is a square term over here. We've got a square term over here. There's a square term over here. We've got a square term over here. And this is minus 2ab. So if this is x squared and this is a squared, that means that the value of x is equal to a if you're comparing it. And if this is b squared is equal to 49, then that means b would be simply 7, right? For example, this would have been 7 whole squared, right? And this is minus 2ab, which is minus 14x. So what is happening? Minus 2 times a, which is x, b, which is 7. So it makes minus 14x. So that is why we can compare these two together, that these look identical. And because this is equal to what you may call a minus b whole squared, I can simply use the same for the above part as well. For example, it is going to be x minus 7 whole squared. And now what is going to happen? Now I can simply rewrite this down, just this part, as what you may call x minus 7 whole squared. And the rest is going to follow as it is. Minus 14 over 2 whole squared plus 24. So that is going to be minus 14 over 2 whole squared is actually 49 plus 24. And you're going to simplify this by writing it down as x minus 7 whole squared minus 25. Clear, guys? Is there anything that you guys do not get from this? Is there anyone who does not understand? Let me know. And The reason that you guys might ask is that we were getting a different answer above when we used middle term breaking, and we got a different answer below when we used completing the square is this answer is just simply factorizing. This answer holds a lot of significance. The reason why it holds a lot of significance is that when we do equations, we are going to learn that using completing the square method actually tells you about the turning points of the curve. So that is why the answer is different from this answer. Is this clear? So we'll come back to this when we do um, what you may call turning points in graphs. Yes, Sad.
Sir, should the value of ax square in breaking the middle term should also be 1?
Yeah, that is what we usually say. We say that the value of a should be equal to 1 in order to avoid hassling. Now, why is that the case? Because usually what happens is that let's just say if the value of a is not equal to 1 or if it's a larger number, at the end it's going to cause an issue for you to simplify it. That is what we say. It can be done without it being a, but this cannot be done. Completing this square cannot be done. This is for your comfort, but you should do it because if you can factorize, if you can simplify it way before you even do middle term breaking, it is going to make it easier for you to factorize it in the end, because once you've broken it down, then you have to factorize it all over again. So having it easier in the first half makes it a bit easier to factorize it in the afterwards. Clear? Is there
Clear.
anyone who does not get this? Yes, people.
Yeah, I have two things to say.
Yes, sir.
So first of all, in the middle term breaking, if the coefficient of x squared is not 1, if it's 2, for example, can't I just multiply, for example, 2 times 10 over here to get 20, and then the sum is 7, and I can do that, because the answer comes as correct.
Yeah, that is what I'm saying, Zoya. It's a bit more optional over here. All right. Uh, you're absolutely right in saying that if you are able to manage, this is for your ease. All right. If you're
Okay.
able to manage it without making the coefficient a, that is why I did not stress that you cannot do this. Over here, I'm stressing that you cannot attempt the question before converting it to um, the coefficient of x squared is equal to a. Yes, sir. And you had one more
Yeah,
thing.
could you do this completing the square with a coefficient that's not 1, like 2?
Completing the square.
Yeah.
Okay. I'll have to think of an example. Wait, let me see. Okay, wait, let us do a past paper question. And let me take one out. Where the coefficient of x squared. I was just about to give you guys a worksheet, but now we're going to do one. Express. Hmm. Expression. Where did it go? Yes, finally. All right. So the question is, this is, I think, a past paper question, that it says 3x squared plus 12x plus 19. And you have to express this in this form. You have to express it in the form of a and whatever it is. All right. So you know that you are supposed to do completing the square. You cannot do middle term breaking or anything. What you're simply going to do is, first off, I know that, this is not 1. So I need to factorize this. But there's an issue. 19 is not divisible by 3. So you can do two things. First, what you can do is that you could do 19 over 3 and, take out 3 and factorize the entire thing. Or you could simply factorize just this part and leave 19 outside. That could work. Like, for example, I could do it like this: 3 x squared plus 4x plus 19. That could work. Now what is going to happen? You can do completing the square method from here on out. How you're going to do it? 3x squared plus 4x. And now 4x is going to be, obviously, you're going to half it. So it is going to be half of 4 adding, whole squaring it, and then subtracting it with the entire thing. So like this. And the bracket comes as it is. And you have your 19 on the outside, plus 19 on the outside. So now what's going to happen? You're going to have what you may call, you're going to complete the square and everything. So now I'm going to isolate this part again. Always remember it's the plus part that is being isolated. All right, wait, let me highlight it. So this is going to be isolated. And what will this look like in turn? This is simply going to be what you may call, if I simplify this, it is going to be x squared plus 4x plus 2 whole squared, because 4 over 2 is 2. So this can be simply again written down the same way that we did over here, like this. But this time around, small tweaking in this is that it's a plus b. So it's a plus b. So this can be written down as what you may call x plus 2 whole squared. All right. Now I can simply rewrite this down as it is. Writing it down below, it's going to be 3 times x plus 2 whole squared minus 2 whole squared, which is technically minus 4 plus 19. So now what you're going to do is simply, I can, solve it further. It is going to be, I can expand the bracket, so it's going to be 3x plus 2 whole squared. 3 times minus 4 is minus 12. So plus 19. So this is going to be 3x plus 2 whole squared minus, plus 7. And that's your answer. Is this clear, guys? Is there anyone who has any issues with this? Zoya, is this clear now?
Yes, sir.
Hani, any issues with this? All right, hopefully you can hear us, Hani. Basit, anything that you would want to ask? Not at all.
No, sir.
All right. And I hope the same goes for Kushi. And I'm done. I'm running. This is clear, right? Because the reason why I'm stressing a lot on completing the square is because this is actually important. Obviously, the rest of the stuff is equally important as well, but completing the square questions come separately. Like the examiner asks them separately. And if you guys remember, I wrote over here, if the examiner asks you to write it in this form, ax plus b whole squared. This is the form that you get, Zoya, when you know the x squared term does not have the coefficient equal to 1. Clear? All right, let's do some questions, guys, so that you guys can also attempt these. Right, I'll give you guys some questions over here. And I'll give you guys questions with the squares, without the, what you may call, where the coefficient of x squared is not equal to 1. Yes, this is a good one. Mhm. And all right, I think this will be enough. I'm giving you guys just 3 questions. Hopefully, you guys are able to attempt them. All right, guys. Uh, the questions are on your screen now. Kindly do them and let me know. These 3 questions. They're very easy to do. They're not extreme, like they're not hard at all. 2 of them are extremely easy. The first one, however, you are going to do what is necessary. Let me know when you're done, okay? Then we'll discuss the answers. Done, sir?
Yes, sir.
Could you tell us? Okay, let's just wait let's just give the others a minute to do so. Then you tell the
Okay.
answer. All right, so we've got a couple of contenders. Saad, can you tell us what the answer to the first one?
4 multiplied by x minus 1 squared plus 3.
Could you repeat that, Saad? Sorry. 4 multiplied by
X minus 1 squared plus 3.
x minus 1 whole squared plus
Plus 3.
3. Okay. Yes. Does everyone agree with Saad or no? Yes. Now, hopefully they agree with Saad. Okay, what about the second one? Yes, Zoya?
X plus 1 whole squared minus
X plus 1 whole squared. Hmm. Minus.
minus 9.
Well done, Zoya. Hopefully everyone agrees with her. And Ranin, could you tell us the last one?
Sir, I didn't do the last one.
Why, Ranin? It was the easiest one. But were you not able to complete it, or weren't you able to do it?
No, I didn't complete it.
What, sorry?
I didn't complete it.
All right. Who else has done it? Is there anyone? Kushi, have you done the last one?
Yes, I got x minus 3 whole square minus 8.
X minus 3 whole squared minus 8.
Yes, sir.
And Zoya, is this answer correct?
Yes.
All right. Hopefully this is clear for everyone. All right. Now, what's going to happen is that we're going to leave it till here for today, and we're going to continue on with this in our next class. In our next class, however, we'll move on to equations, and through equations, we'll move on to graphs and inequalities and just, fly off there. All right, guys. So we'll keep it till here for today. Uh, as always, keep smiling. If there's a makeup class or anything of that sort, I'll inform you on Google Classroom. Hello, Hafiz, everyone. Goodbye. Have a nice week. I'll see you on our next class.
Love this.
Hafiz. Bye bye.
Allah Hafiz, sir.
Hello, Hafiz.